Now, let's get to know Lucas the Giganotosaurus. This model was restored at a scale of 1 to 35, based on our latest knowledge of Giganotosaurus. First, let's look at its head. We have mentioned before that in early restorations, its head was long or relatively short, but now we can complete the missing part of Giganotosaurus based on the intact skull of Meraxis. For example, the tip of its mouth had not been found in Giganotosaurus, so in early restorations, the mouth had been restored in different shapes. In some restorations, the mouth was sharp, and in others, it was round. The jugal bone of Giganotosaurus was also absent. There used to be a noticeable upward gap here in previous restorations, which made it look particularly fierce. There were several exposed teeth, which were actually caused by the deformation of the fossil. Its jugal bone was not found in the early years, so it was restored at a very low position, because it was based on the preserved jugal bones of Acrocanthosaurus or Carcharodontosaurus. We now know that this part of Giganotosaurus was relatively flat. In early restorations, its temporal fenestra was made into a round opening, which caused its skull to be elongated backward considerably. Now, according to the skull of Meraxis, we made its temporal fenestra relatively narrow to make its head look more natural and more like a triangle. The front half of the lower jaw of Giganotosaurus was found, a very complete front half of the dentary bone, which reveals several pieces of information. One is that its lower jaw was very large when viewed from the side, indicating that it had a relatively square and large head. Its lower jaw looked relatively narrow overall, but the second half was unknown. According to other Carcharodontosaurids, it might be wider in the second half, just like this. Its lower jaw had a characteristic, that is, its teeth were concentrated in the front half of the mouth. Unlike most dinosaurs, the mandible teeth ended here, and the maxillary teeth might end in this place. The mandible teeth of Giganotosaurus might end at this position. Scientists have not described too much about this, but we can speculate that it might be directly related to its behavior. It might be better using this part to dig and pull. For example, when we humans use pliers, we may use pliers to clamp a point to tear things off. Maybe Giganotosaurus did such things more when biting its prey or pulling pieces of meat from food. In addition, if it encountered a small animal, it would swallow it whole, so most of its maxillary teeth would not participate in large-scale occlusion and tearing. Of course, that is just a speculation. In addition, on the skull and the left and right nasal bones of Giganotosaurus, there were 2 rows of ridges, with some space between them. The surface of these 2 ridges was even rougher than its facial structure. This structure must have been covered with keratin when it was alive. Just like many animals today, there are many structures that look like cracks on the bone core inside ox horns. When they are alive, the keratinous sheath is fixed outside, just like this structure. When it was alive, this part might be in bright colors like yellowish. The antipodal fenestra of Giganotosaurus was very large, and the nose part in front of its maxilla was shorter. The fossil of the trunk of Giganotosaurus is very well preserved, so we can accurately infer the shape of the trunk. Among Carcharodontosaurids, the neural spines of Giganotosaurus were not too tall. Its whole body looked slightly square, and its back was relatively straight. Its pelvis and the neural spines above it sloped slightly downward. After restoration, we know that Giganotosaurus had a long ilium, unlike Meraxis, its earlier relative. Meraxis had a very short ilium, which led to the fact that its legs might be slender. Giganotosaurus was much stronger than these dinosaurs, with a long pelvis and very thick and powerful hind limbs. Moreover, its hind limbs looked slightly shorter than the length of the entire body, which is also a characteristic of Giganotosaurus, indicating that it might not be an animal good at running. Of course, that is just an assumption. At least, it couldn't run very far. Giganotosaurus had very short forelimbs, and like those of Tyrannosaurus rex, they accounted for a very small proportion of the body. Its shoulder blade was entirely encased in flesh. Unlike early restorations, which often protruded the scapula, as in most animals today. The shoulder blades of a healthy animal are not exposed, but if you look sideways, you can still see some of the structure of the shoulder blades. You can see that its shoulder blades actually looked very narrow and short, which means that its forelimbs might be more flexible. Because when the dinosaur was moving, the shoulder blades slid to a certain extent, and they were relatively small. They might not be particularly fixed, indicating that the motion range of its forelimbs was slightly larger than expected, but it was limited to backward movement. Generally, dinosaurs did not extend their arms forward. Besides, its forelimbs were very small and might not play a big role in hunting. Although the forelimbs had a relatively flexible range of motion, they might have other functions. In addition, its epidermis was generally made based on Allosaurus, with fine scales on the surface. We did not adopt some scholars' opinions to make primitive feathers on its neck and tail, because there is still no evidence for feathers at present. Besides, according to the proportions of Meraxes, its feet were restored with a size like this. You can see that each foot had 3 toes. These 3 toes were not as thick as those of Tyrannosaurus rex. Pads on the soles corresponded to each phalange in size and scale. Its second toenail was slightly longer, which was also restored based on Meraxes. Of course, it is not clear for the time being whether this characteristic is unique to Meraxes, or it is a characteristic shared by Giganotosaurini and all Carcharodontosaurids. The above concluded the restoration process of Lucas the Giganotosaurus. Thank you all.